You're sitting in this room right now, but maybe in another universe you stood up. Maybe you never opened this video. Maybe you're living a completely different life. That's the multiverse idea. Sounds beautiful. But the real question is this: is this actually mathematics, or just a well-written story? Because can you call something a universe if you can't prove it? And the more disturbing question, if those universes exist, and you exist there too, which one is the real you? I'm Richard Feynman, and I want to be honest with you about something most physicists won't say out loud. The multiverse might be the most seductive idea in all of science, and seductive ideas are dangerous, because they feel true before you've checked whether they are. So let's check. Bear with me, because this requires starting somewhere you might not expect. Start with a coin flip. You flip a coin. Heads. Simple. Random. Done. But quantum mechanics says something stranger happened. Before you looked, the coin wasn't heads or tails. It was both. Superposition, a genuine mixture of two possibilities existing simultaneously. You look, it collapses to heads. One outcome, reality chosen. But here's the question that launched 1,000 arguments. What happened to tails? The Copenhagen interpretation, Bohr, Heisenberg, says tails simply ceased. It was a possibility, then it wasn't. The wave function collapsed. Tails is gone. Don't ask where. There's no where. It's just gone. Most physicists accepted this for decades. Calculate. Don't ask questions. Shut up and compute. I was told this myself as a student. I didn't like it then. I still don't like it now. Because it just disappeared is not an explanation. It's a surrender. Then in 1957, a young graduate student named Hugh Everett III sat down and asked the uncomfortable question, what if tails didn't disappear? What if both outcomes actually happened? What if the universe split, heads in one branch, tails in another, both real, both continuing, both complete universes, evolving forward in time, never communicating with each other again? The many worlds interpretation, every quantum event, every coin flip, every radioactive decay, every decision an electron makes, the universe branches, splits, multiplies, billions of times per second, in every atom, in every corner of reality. You're sitting in this room, but in another branch, you stood up a moment ago. In another, you closed this video. In another, you were never born at all. All of them real. All of them happening. Right now. Everett submitted this to his advisor, John Wheeler. Wheeler was my mentor. Brilliant man. He loved radical ideas. But even he was nervous about this one. I met Everett once, briefly. A party, I think. Princeton, maybe. He was quiet, intense, the kind of person who had clearly been living inside a single idea for years. I asked him directly, do you actually believe it, the branching? He looked at me with this expression I've never forgotten. Not defensive, not evangelical, just tired of the question. The mathematics believes it, he said. I just wrote it down. That answer stayed with me, because it's either the most honest thing a physicist can say or the most dangerous. I'm still not sure which. The physics community mostly ignored Everett. He left academia, went to work for the Defense Department, died relatively young, but his idea didn't die, because it had something powerful behind it, mathematics. And this is where I need you to pay attention, because this is the actual argument, not the philosophy, not the poetry, the mathematics. Let me give you an analogy. Bear with me here. Imagine you're an accountant. You've been keeping books for a company for years, every transaction recorded, every number balanced. The ledger is perfect. One day someone asks, where did the money go when we spent it? You say, it went to the supplier. It left our account. Gone. But your ledger doesn't show it gone. It shows it transferred. It's somewhere else now, in another column. Still in the system. The total always balances. Now imagine a physicist asks the same question about quantum possibilities. Where did the other outcomes go when the wave function collapsed? Copenhagen says, gone, spent, vanished. Don't ask where. Everett says, look at the ledger. The mathematics shows a transfer, not a deletion. The possibilities went somewhere. They're still in the system. The equation always balances. Everett wasn't adding something exotic. He was refusing to add something unjustified. He looked at the equation and said, I will not write in a collapse that the mathematics doesn't contain. That's it. That's the whole move. And it leads to infinite universes. When you write down the Schrödinger equation, the equation that governs how quantum systems evolve, it never collapses. Never. Not once. The mathematics contains no collapse. No moment where one branch wins and the other disappears. You evolve a superposition forward in time. The mathematics gives you a larger superposition. Both outcomes evolving forward, both there in the equation. The collapse, the moment where reality chooses, is something we added, by hand, as an extra rule, because the experiment seemed to demand it. But Everett said, what if we're wrong to add it? What if the equation is right? What if we should trust the mathematics? If you trust the mathematics completely, you get the multiverse. Not as a poetic idea, as a literal consequence of the equation. This is the argument that makes serious physicists take many worlds seriously. It's not imagination, it's mathematical honesty, and it's deeply uncomfortable. Imagine you're reading a novel. You reach page 200, and the hero makes a choice. He turns left instead of right. The story continues with him turning left. But what about right? That possibility was real on page 199. Where did it go? A Copenhagen physicist says, it vanished. The story chose left. Right never happened. An Everett physicist says, the book split. Somewhere, there's another copy of the novel where he turned right. Both books are real. You're just reading one of them. Now, and here's what keeps me up at night, which of those physicists is making the stronger claim? The Copenhagen physicist is adding something, a collapse, a moment of cosmic choosing, something the mathematics doesn't contain. The Everett physicist is taking away something. He's saying, don't add the collapse, just trust the equation. In physics, we have a principle, Occam's razor. Don't multiply assumptions beyond necessity. The simpler explanation wins. By that principle, many worlds should win. It requires fewer assumptions, just the equation, nothing else. But here's my problem. Here's where I get honest with you, in a way that might surprise you. Fewer assumptions doesn't mean more real. I can write down a mathematical universe with 17 dimensions, purple gravity, and time that runs backward on Tuesdays. The mathematics is perfectly consistent, no contradictions anywhere. Does that mean those 17 dimensions exist? Of course not. Mathematics is not the same as reality. Mathematics describes reality, or sometimes fails to. The test, the only real test, is experiment. And here is the brutal truth about the multiverse. We cannot test it. Not yet. Maybe not ever. Those other branches, the universe where you stood up, where I never won the Nobel Prize, where the dinosaurs survived, they are, by construction, causally disconnected from us. No signal can travel between branches, no experiment can reach them, no measurement can touch them. A theory that makes no different predictions than its competitor is not a better theory. It's just a different story. I think about this the way I think about a detective story. Imagine two detectives investigating the same crime. Detective 1 says, the butler did it. Here is the murder weapon. Here are the fingerprints. Here is the motive. Every piece of evidence points here. Detective 2 says, actually there's an invisible man. He committed the crime. He left no fingerprints because invisible men don't leave fingerprints. He had no motive we can detect because invisible men think differently than us. Both stories are internally consistent, but only one of them is science. The multiverse, as beautiful as it is, risks being Detective 2's story. Unfalsifiable, untestable, internally consistent, but forever out of reach. Now, I want to be fair, because the story doesn't end there. There are physicists, serious ones, people I respect, who argue the multiverse is not a hypothesis at all. It's a prediction, a mandatory consequence of accepting quantum mechanics as universally true. If quantum mechanics applies to everything, and we have no evidence it doesn't, then the Schrödinger equation applies to the entire universe. And the Schrödinger equation never collapses. Therefore, all branches exist. It's not a choice. It's forced. This is an uncomfortable position because it means the multiverse isn't something we added to the theory. It's something we're not allowed to remove. Like discovering your equation predicts a particle you didn't know about. You don't get to cross it out just because you haven't found it yet. Gell-Mann did this with quarks. The mathematics demanded them. We looked. There they were. Maybe the mathematics is demanding the multiverse, and one day, somehow, we'll find a way to look. I had a student at Caltech, sharp kid, loved quantum mechanics, came to my office hours one afternoon looking genuinely troubled. Professor Feynman, he said, if many worlds is true, then there's a universe where I failed this course, where I never became a physicist, where I made every wrong choice. Probably, I said, that's awful. Why? Because that version of me is suffering. Somewhere, right now. I thought about this, really thought about it. Not the physics, I knew the physics. but the human weight of what he was saying. You know what else is true? I said. There's also a universe where you won the Nobel Prize, where you solved the measurement problem, where you figured out what we're all sitting here confused about. He was quiet for a moment. Does that make you feel better? I asked. A little, he said. Is that the right reason to believe it? No, I said. That's exactly the wrong reason, but it's a very human one. He laughed. We got back to the equations, but the question stuck with me, and I'll come back to it. Maybe. I genuinely don't know. But here's what I keep coming back to. The question underneath the question. Why does this idea feel so right? Because it does. It feels right in a way that's almost suspicious. Sit with it for a moment. Every choice you've ever made, every path not taken, every word unsaid, every door closed, exists somewhere. Nothing is lost. No possibility dies. Every version of you is real and living and continuing forward. That's not physics. That's comfort. And comfort is not evidence. The multiverse solves a philosophical problem we have, the problem of lost possibilities, the grief of roads not taken, with a physical claim we can't verify. That should make us careful. It doesn't mean it's wrong. Some true things are also comforting. The sun really does rise. The people we love really do exist. Comfort and truth occasionally coincide. But when a theory's greatest selling point is how good it makes you feel, check your wallet. Something might be missing. So where does that leave us? Here is what I actually believe. My honest position after thinking about this for years. Quantum mechanics is the most precisely tested theory in the history of science. It works, spectacularly, to 12 decimal places. The Schrödinger equation is real. The superposition is real. The measurement problem, the question of why we see one outcome when the mathematics contains all of them, is a real unsolved problem. Many worlds is one solution to that problem, a serious solution, mathematically motivated, taken seriously by serious people. But it is not the only solution, and it is not confirmed, and the confirmation may be permanently beyond us. The Copenhagen interpretation has its own problems. The arbitrary collapse, the undefined boundary between quantum and classical, the uncomfortable vagueness about what observation means. There are other interpretations, pilot wave theory, relational quantum mechanics, cubism, each with different problems, none confirmed. We don't know which is right. Anyone who tells you we do is selling something. What we know is this. At the bottom of reality, something very strange is happening. The universe is not classical, not deterministic, not simple. At the quantum level, possibilities are real until they aren't, and we don't fully understand why they stop being real. The multiverse is one answer to that strangeness. Maybe the right one. And now the question you've been carrying since the beginning. If those universes exist, if you exist in all of them, which one is the real you? My student asked me this, standing in my office doorway, about to leave. Professor, if I exist in 1,000 universes, which one is me? Which one counts? I didn't answer right away. I made him wait, not to be dramatic, because I actually didn't know, and I wanted to think. Finally, I said, which performance of Beethoven's Fifth is the real one? He frowned. What? The symphony. 1,000 orchestras have played it. 1,000 different rooms, different instruments, different tempos. Which one is the real Beethoven's Fifth? They all are, he said slowly. Right. Because Beethoven's Fifth isn't a performance. It's a pattern. It exists wherever the conditions are right to produce it. The orchestra doesn't own it. The concert hall doesn't own it. The pattern owns itself. He stood there thinking. So I'm a pattern, he said. You're a pattern, I said. A particular arrangement of memory and habit and history and love. That pattern exists wherever the conditions align to produce it. In every branch where the coin flipped the right way, where your parents met, where you made enough of the same choices, there you are, playing. That's either beautiful or terrifying, he said. Yes, I said, that's how you know it might be true. I think this question contains a hidden assumption, that there is a real you, a single, central, definitive version, the canonical edition. But maybe that's wrong. Maybe you're not a thing that exists in one place. Maybe you're a pattern, a configuration, a particular arrangement of information and memory and habit and love. And that pattern, your pattern, exists wherever the conditions are right to produce it, like a symphony that can be played in any concert hall. The music doesn't belong to one orchestra. It belongs to the pattern of notes. If the multiverse is real, you are that music, playing in every branch where the notes align to produce you. Not fractured, not divided, multiplied. Every version equally real, equally you, none more original than the others. That's not loss, that's abundance. Whether it's true, whether the universe is alone or endlessly multiplied, I don't know. Science doesn't know. The mathematics suggests but doesn't confirm. The experiments are silent, but the question is real. The strangeness is real. The measurement problem is real and unsolved, and pointing at something deep. The universe might be alone. One history, one timeline, one you, or it might be vast beyond imagining, branching at every quantum moment. Infinite versions of this room, this conversation, this exact second. Both possibilities follow from the same equation, written down by Schrödinger in 1925, sitting there still, waiting for us to understand what it means. I've spent a lifetime with that equation, and I still don't know, but I know this. The fact that we can ask the question, that a pattern of atoms arranged into a human being can look at the cosmos and wonder if it's alone, that is the most remarkable thing I've ever encountered. The universe examining itself, wondering about its own loneliness. Whether it's alone or not, that wondering is real, and that's enough to keep asking.